Welcome back to Lumicore Labs, Day 4. Last time, we built a tip calculator using variables and user input. Today, we're going under the hood. We're going to talk about data types, the different kinds of information Python understands, and type conversion, how to switch between them. Understanding data types is the difference between code that works and code that crashes mysteriously. Let's get into it. Python has 4 essential data types you'll use every single day. First, strings, for text. You can use single quotes, double quotes, or triple quotes for multiple lines. Second, integers, whole numbers, positive, negative, or 0. Third, floats, numbers with decimal points. And fourth, Booleans, only true or false. Capital T, capital F. Strings are sequences of characters, letters, numbers, symbols. Integers are for counting, like age, year, and negative. Floats are for measurements, like rating, pi, and temperature. And Booleans are for yes or no conditions. For types, that's it. Master these, and 90% of your Python code is covered. Sometimes you're not sure what type of variable is. Python gives you a built-in tool called type. Just wrap any variable, and Python will tell you exactly what you're dealing with. C. str, int, float, bool. This function will save you hours of debugging, especially when you're working with user input. Here's the crash I keep warning about. I ask for age, then try to add 1 to it. Looks fine, right? But input always returns a string, even if the user types a number. Watch what happens. Type error. Python is screaming, I cannot add a number to text, because 25 is a string, not the integer 25. To fix this, we need type conversion. The solution is int. It takes a string that looks like a number and turns it into an actual integer. Now Python can do the math. You can chain it int, input, in one line. This pattern is so common you'll write it hundreds of times. Now let's look at 3 common mistakes that even experienced developers make when working with type conversion. These are the kind of errors that can waste hours of your time if you don't know what to look for. Pitfall number 1. Trying to convert a string that doesn't look like a number. Here I'm passing the word hello to int. What do you think will happen? Python has no idea how to turn the letters HELLO into an integer. Let's run it and see what happens. There it is, a value error. Python is telling us, I cannot convert this string to an integer. It makes no sense. This happens all the time when users type unexpected things. Pitfall number 2 is subtle but important. Look at this. I have the float 3.99. I pass it to int. What do you expect to happen? You might think Python would round it to 4. Let's see what actually happens. And there's the surprise. It prints 3, not 4. Int does not round. It truncates. It simply chops off everything after the decimal point. 3.99 becomes 3. 3.1 also becomes 3. Minus 3.99 becomes minus 3. Everything after the dot just disappears. Pitfall number 3, Boolean conversion. This one is especially tricky for beginners. In Python, every value has an inherent truthiness. Certain values are considered falsy, meaning they evaluate to false when converted to Boolean. Let me show you. An empty string is false. The number 0 is false. An empty list is false. And the special value none is also false. These are the main falsy values you need to remember. Now watch what happens with non-empty values. A string with even a single character, true. A non-zero number, true. A list with items inside, true. Almost everything in Python is truthy except for those few specific falsy values we just saw. It's time to put everything from today into practice. We're going to build a real-world temperature converter. This is a genuinely useful tool. You could use it to check the weather in another country, to convert a recipe from a European cookbook, or just to understand a science article. The program takes a temperature in Celsius, which is what almost the entire world uses, and converts it to Fahrenheit, which is what they use in the United States. As a bonus, we'll also show the equivalent in Kelvin, the absolute temperature scale that scientists use in laboratories and research papers. I'm asking the user for a temperature and immediately converting it with float. Pay close attention to why I chose float and not int. Temperatures are rarely whole numbers. Someone might enter 25.5 degrees, or 37.2 degrees, or negative 10.8 degrees. If I used int, any decimal would crash the program with a value error. Float smoothly handles both whole numbers and decimals. This is a critical design decision, choosing the right data type based on how the data will actually be used in the real world. Here's the Fahrenheit conversion formula. Multiply the Celsius temperature by 9, divide by 5, and then add 32. I'm wrapping the multiplication and division in parentheses to make the order of operations crystal clear. Python would do the math correctly even without the parentheses. Multiplication and division happen before addition, but adding parentheses makes your code easier to read, especially for someone who doesn't have the order of operations memorized. Converting to Kelvin is surprisingly simple. Just add 273.15 to the Celsius value. That's it. No multiplication, no division. Let's test this with a realistic temperature. I'll enter 25.5 degrees Celsius. That's a warm, pleasant day, maybe late spring or early summer. And there are the results. 25.5 degrees Celsius is 77.9 degrees Fahrenheit. That's perfect beach weather if you're in the United States. And for the scientists watching, 298.65 Kelvin. The program works exactly as expected. Let's take a moment to appreciate what we just built. This is a real tool. You could actually use this to check the weather in another country or to understand a recipe written in a different measurement system. And it only took about 10 lines of code. This is the essence of programming. Small amounts of well-written code can solve genuine, everyday problems. You're no longer just learning syntax. You're building things that work. Day 4 complete. You now understand the 4 fundamental data types and how to convert between them. Next time is practice day. You'll solve data type challenges on your own. If you like this video, hit the like button and subscribe to Lumicore Labs. And tell me, what's your favorite data type so far? See you on day 5.